In today's GibbsCAM Tech Tip, you will learn how to program sub-spindle pickoff operations starting from solid models. First, you will need to open the solid model in GibbsCAM. It's best to select the proper machine in the document control dialog before opening the file. In this case, I'm selecting a Doosan twin spindle as my machine before opening a SOLIDWORKS part file named New Millturn. Once the part is open, you will need to position the part properly in the main spindle. I find the easiest way to do this is to open the Coordinate Systems dialog and select XY plane for the main spindle. With Face Select turned on, select the front face of the part before right mouse clicking to align face to CS. Now use Modify Shrink Wrap to set the starting stock dimensions. Open the Document Control dialog and set the desired XD and Z clearance values, and then set the graphic part face distance to 0. Double-click the solid model to place it in the body bag and rename it Part in Main. Select the part in the body bag and use Ctrl-D to duplicate it. The new solid in the workspace is now selected. Use Modify Translate to move this new solid into position in the sub-spindle. This will always be the length of the part in the Z-axis as a positive value. Once this new part is in position in the sub-spindle, select the ZX plane in the Coordinate Systems dialog, right mouse click it, and change CS XYZ to make the solid belong to the sub-spindle. Double-click the model to put it in the body bag, where you can rename it to Part in Sub. Now double-click both solids to put them back into the workspace. Open the Workgroup dialog. Rename Workgroup 1 to Blank since we will leave this unused. Click on New Workgroup and rename it to Check, as we will use this geometry to make certain everything is set up correctly for simulation. With the ZX plane for the sub-spindle still active, turn on the profiler and Slice Spun Body. Select the green profile and then right mouse click on it to extract geometry. Now switch to the ZX plane for the main spindle. Select that green profile and right mouse click on it to extract geometry. Turn off the profiler. Notice the geometry for the main is blue while the geometry for the sub is magenta. This is how GibbsCAM shows geometry in the active CS versus an inactive CS. Open the Document Control dialog and set the graphic part face distance to 2. Notice how the solid model and the geometry for the part in sub move with the stock for the sub-spindle. While in the Document Control dialog, for the main spindle, set the Z max to 0.025. This will be the stock to remove with facing. Set the Z min to Z minus 1.65, which is the length of the part plus cutoff tool width plus stock amount to face in the sub-spindle. For the sub-spindle, make sure Initial Stock is unchecked, since the stock is being transferred from the main spindle. Also, for the sub-spindle, set the Z max to 0.025. This will be the stock left by the cutoff tool to remove with facing. Set the Z stickout length to 1.025, holding on to 0.5 of material with the sub-spindle, with the part being 1.5 long plus 0.025 stock for facing with the sub-spindle. Now that everything is set up correctly, we will program the part. First, I will load a facing process for the main spindle. Select the geometry, set the machining markers, and do it. Then I will load a turning process for the main spindle, select the geometry, select the machining markers, and do it. Next, I will load all of the processes for picking off the part with the sub-spindle. These consist of a sub-spindle in process to a grip Z of 0.5, a sub-spindle pull with a shift distance of 1.675, which is part length plus cutoff tool width plus 0.025 stock for facing on the sub-spindle plus 0.025 stock for facing the next part, a contour part process with cutoff selected, a sub-spindle return with part in main. I will select the geometry on the front of the part for the cut-off contour operation, and then do it. Finally, I will change the ZX plane for the sub-spindle, load a facing process for the sub-spindle, select the geometry, set the machining markers, and do it. Using OpSim rendering with stop at part, load, unload selected, and overlay geometry turned on, I can clearly see that everything is set up correctly for machining in both the main and sub spindles. Thanks for watching this GibbsCAM Tech Tip. If you have any questions, please feel free to contact your local GibbsCAM reseller.